Oh, that's so good. One of the bonuses of being a teacher is I get multiple discs. I thought I was going to say something about coffee, didn't you? All right, here we go. On 11 through 19, it says if f of x equals 6x plus 7 and g of x equals x squared minus 4. Well, these look very similar, and in fact they are. They are both functions. And a function can be named anything. You can call this Callista of x. You can call this Alyssa of x. You can call it a of x. You can name the function anything you want, and normally it's going to be named by a single letter, and most of the time it will be f, because f is the first letter in the word function. So these are two different functions, this one called f, this one called g, and they both use x's as the input, and that's why the x is in the parentheses here on the left-hand side. So what this is telling us is that you have a function that uses x's as the input, and here's how it's going to use the x. Anytime you put a value in for x, you're going to multiply it by 6, and then you're going to add 7 to that answer. Over here in this function, it's doing something different. Here's a function named g that uses x's for the input, and here's what you're going to do with the x's. First, you're going to square them, and then when you get that answer, you're going to take 4 away. Well, that works real nice so long as you have just numerical values to take the place of x. And that's all that these things in the parentheses are going to do. They're going to take the place of the x in the actual expression. Once you start having letters, though, or a combination of letters and numerical values, it's still doable. It just requires a couple more steps. So I'm just going to work a couple of examples. Suppose I have this function f, and it uses x's for inputs, and it's going to double the x's and then take 3 away. Now the first thing that I have to do, I have an exercise that says f of negative 2. So I go to the function that has this same name, and for whatever's in the parentheses with that function, I'm going to replace it with this new input value. So for our example, it's going to mean that I take the x out and I replace it with a negative 2. Now all of a sudden there's math to do. So I do the math and get my answer. 2 times negative 2 is negative 4. And I still need to take 3 away from that. Negative 4 take away 3 is negative 7. So f of negative 2, when I use negative 2 as the input for this function, here's the answer that I got, negative 7. Simply put, you take this value, replace the x with it, and then do all the math that you can do. But what if it's a variable instead of a value, like f of a? So I need to find the function that has the same name. Here it is. And I need to take its input variable out and replace it with the one that I have in the exercise. I'm going to take the x's out. I'm going to replace them with a's. So here we go. 2. Now take this x out. I replace it with an a. And then I write the rest of it. For an exercise like this, I would be done. There's still no math that I can do, even though I took the x out and I put the a in it. This term has an a, this term does not have an a, so I can't go ahead and subtract them. This is it. This is the whole answer. Let me write example 1. Example 2. Well, what if it's something like f of x minus 1? So I would go find the function that has the same name. I would take the input variable out over here, and I would replace it with what's inside my parentheses now. So here we go. 2 times, take that x out, and now replace it with x minus 1. And then I'll write the rest of it. Now, if you're not clear, please stop me and ask me now. Now, there is no work to do on the left-hand side here. This is just for notation purposes. Is there any math that can be done on the right-hand side? Yes, I agree. You remember what it's called? Distributive property. Very good. We can go ahead and do this multiplication here. So this is going to equal 2 times this. So how would I write that? 2x. And then 2 times this. What would that be? Minus 2. All the multiplication is done, so I can get rid of the parentheses, and now I have a minus 3 at the end.
Pardon this interruption. If you are a senior that participates in any extracurricular activity, including Beta Club, Ag, FCCLA, athletics, please report to the gymnasium foyer at this time. Thank you. All seniors that participate in these activities. Thank you.
Now what? Are there any more x's besides this term right here? No. So we can go ahead and bring that down in the answer. And now what's left? Negative 2 minus 3, which is negative 5. And we write that down as minus 5. Example 3. Example 4. What if it looks like this? F of G plus 2. Here's what this is saying. You take that function with this name, so this one right here. You use the G for input, so you'll take that X out and you'll replace it with the G. So 2G minus 3. And then to the whole thing, add 2 plus 2. This is a completely different type of exercise than this is over here. Right here.
Oh, okay.
In example 3, everything we were doing was on the inside of parentheses. In example 4 here, we've got something on the outside of parentheses. And that means do this and then add 2. We don't do any work on the left-hand side. On the right-hand side, there are no more G's over here on the right-hand side, so they come down into the answer. And here's the math that we can do. Negative 3 plus 2 is negative 1, so we write it down as minus 1. That's example 4. I'm going to do one more example, and then I think you'll have enough to do your work. I think you probably could have done it anyway, but anyhow. Right. Let's suppose I have 2 different functions. R. How about R? R of x equals 3x. R. And I have f of x plus r of x. So there's no work to do on the left-hand side. It's just telling us what we need on the right-hand side. I need f of x, which is 2x minus 3. And I need to add to that r of x, which is 3x. Now all of a sudden, I have x's here and x's here. I can go ahead and combine those. 2x plus 3x, 5x. And then I have this 3. It's a constant. There are no more constants on this side to combine it with, so all I can do is write it down just the way that it is. Example 5. Any questions?
You're going to do all 9 problems?
Yes.
Okay.
11 through 19. If you get tripped up on number 16, just let me know. It's a little unfair that they do something like this already. But